So for a little over a year now, Brad and I have been part of it started out as a team of 4 people at Northwestern Mutual, where we've been working to basically go into Amazon, provide Adam's first cloud environment, and provide basically a set of REST APIs in a highly available fashion. And we've chosen to do that in Node.js, and so we are going to go over kind of what caused us to start this project and kind of what our approach was. And so it all started on March 25th, 2015. A bunch of us went into a room, found out that we had acquired a company, and we had to start looking at a way to provide data in a highly available fashion to integrate with our new acquisition, LearnVest.
So the goal was to integrate. LearnVest essentially has a really cool digital kind of client experience for planning. They were really kind of innovative with the millennials. They have essentially like 1 million clients, who's using their product. And we really wanted to bring their client experience into Northwestern Mutual's financial planning and products. Kind of have like an old school, very old financial company really trying to find re-innovation with kind of like a startup culture. So kind of compare that. You have LearnVest, a lot of their solutions, everything they had was in the cloud, highly available. Northwestern Mutual, we have a single data center with many maintenance windows causing all sorts of outages. LearnVest is lightweight web runtimes with the latest modern frameworks. Here we have heavy server runtimes meant for large batch consumption. This was meant, essentially built up over years and years of batch processing. Automated infrastructure and LearnVest, we have classic infrastructure builds that take, weeks, if not months, to complete before you have anything that you can run your applications on. LearnVest has got application infrastructure designed and built for failure. They expect it. It's a way of life, more or less, as far as coding. And I'm more or less tried to, design and built to try to prevent failure and never really succeeding. I mean, it's inevitable things are going to fail. You're better off starting with that mentality to begin with. So we're really trying to get all this product data, the client data, and essentially all of our aspects of our data essentially highly available. So how do we essentially merge these two things together and get to further towards what LearnVest was doing?
And throughout the whole process, in the very beginning, we didn't have a lot of requirements. Our only requirement was to be available. Some of you may be wondering why Brett Hart was on that slide. But if you were growing up in the mid-90s, right, he was there every Sunday. We had either more than just Sundays, but we thought that 100% availability provided kind of a base requirement for us and actually gave us a lot of kind of what we needed to build out and architect our solution. So early on, we had decided on microservices. We wanted to split our application into small services that could be reused, remixed, and shared. It enabled small, nimble, decoupled teams and processes. Each one of our microservices is a separate repo. We wanted to make sure that the runtimes were very lightweight. They needed to start in seconds, kind of unlike our existing runtimes where sometimes they would take minutes to start up. And then they had to be stateless and backwards compatible. If they weren't backwards compatible, we actually had to, that's when we would basically trigger a major revision and you would have to basically have customers upgrade to the latest one. So what we were looking at for a runtime was Node.js. We wanted modules that cannot be blocking. We were looking for asynchronous I/O. The module pattern encourages lightweight and packages and provides a small footprint. We broke up our application to, if we had anything that was shared, it was broken off into a separate module. It provided the seconds to initialize that we wanted in our microservices. Excellent performance. We've done a lot of testing internally where with, I believe it was 6 instances of our microservices, we were hitting 150 transactions per second fairly easily. Our testing tool actually broke. So we actually can't use the existing testing tool that we're using inside the home office. At some point, we'll have to look at something else to try to see what we can actually hit. But that was kind of an interesting experience for us. Never before had we actually broken the tools that we were trying to evaluate our performance with. And then on the bottom is kind of just some of the frameworks we're using. Express for our web application, async, that's how we're, anything that we need to do in parallel, if we need to basically schedule fast in series, waterfall, to basically take results from one series task and pass it to another, bunyan for logging, we're using MySQL as our database, body parser, and then config memwatch. since we don't have a lot of insight into our container as far as the actual VM that Node's running, that provides us an ability to look at so many consecutive garbage collections and basically we admit an event if we notice that the heap's continuously increasing, and then underscoring util.
So something that I guess we had to kind of learn along the way. I mean, we've seen a lot. I mean, there's obviously lots of examples on the web about Node, and we've even brought in, at least into NM, like a couple different coaches, more or less, and essentially teachers about Node to provide some insight. And it was interesting that their production considerations were next to non-existent. They didn't know of a lot of people who were trying to run Node in an enterprise in any large scale. So some things that we found out kind of along the way, and these are just, honestly, some of them are no-brainers, but things that they hadn't even considered and thought about, like logging. One of the biggest vendors hadn't even really done a lot of logging inside their components, and yet when you're a REST provider, essentially doing hundreds of transactions a second, if something goes wrong, how are you going to be able to diagnose without some insight into what's going on? So we, some common frameworks, Bunyan, Winston, Log4j.js. We're using Bunyan just because we wanted to have data-driven logging rather than just a bunch of lines coming out to the kind of a log aggregator. Handle SIGTERM for graceful shutdown. When you start scaling this up and you start having a lot of different instances, when failures happen or you have a shutdown that's pre-prescribed, you want to be able to have all of your existing connections, essentially shut down existing connections, let everything kind of pool out and let all the different connections essentially exit out and get all their payload, and then cut off the server and bring it down gracefully. If you didn't and you just don't handle SIGTERM, essentially the moment that the OS is calling out for stop your processes, it's just going to cut everybody off instantaneously, and everybody's going to get essentially a lot of errors thrown back to them the moment that happens. Select and review your NPM modules carefully. I mean, it kind of goes without saying, but there is so much crap out there, and without looking at it, you can essentially bring a lot of unknown variability into your product. Now, I understand that there's a lot of code, and there are certain modules essentially that are generally accepted by the community. We always try to look for the usage across the community. Is it heavily committed to? Is it heavily used? And does it have a good response as far as issues and notifications and responses?
You guys affected by the patch?
But left that. I know we weren't. Luckily. And that kind of comes down even to the second point. Lock down your NPM dependencies. So if you're doing just basic NPM installs and you're not actually watching your semantic versioning, you're probably just pulling the latest, at least the minor patch by default. And you could, a lot of people I've seen just accept majors on a whim. I mean, that's okay. Like when we kind of came up with a policy that when we start essentially a new release schedule, we'll look at and essentially say, we'll open this up to the latest releases, we'll get up to date, and then we're going to start locking it down to have this thing be controlled. So shrink wrap is an awesome way to do that through NPM to lock down your modules, and then use another great utility is the NPM check updates. Essentially, look to see what's out of date when you come to the new release, update, and then at least you're not staying too far behind. Another interesting one. Not a lot of people showing you how to actually test a Node.js application, at least somewhat easily. A lot of convoluted ways. Two awesome utilities we found. Supertest. Essentially, you can test a Node application without actually essentially firing it up. Essentially, is able to simulate the entire request process. It will also allow you to be a utility if you want to run it against an active service. So whatever way you want to plug into it, it's really easy. We'll show an example in a minute. And proxy choir. You don't want to test your entire application in one swipe. I mean, the modules, you're keeping them nice and compact and resource driven. You want to be able to have a test that tests just that portion. And proxy choir is a great way to be able to take all those required dependencies that you really don't want to have to worry about because they've been tested elsewhere, and get them out of the mix of your current test. And lastly, Node environment, set it to production. This has been more of a recent one of Express.js is just a blatant example as far as in their trunk master line right now. They've literally looked at Node environment to production, and they will disable view caching if that's not set to production. So Node environment, and it's awesome because they have another module, you know, that a lot of people use, config, which uses node-env to be able to switch all your configs based on environment. So if you're like us, who was like, int is this, QA is this, perf is this, prod is this, well, we never set node environment ever to production, which meant you don't get any of the gains of view caching, as well as it turns on a bunch of this debug level process monitoring that explodes your process tree. So set your node environment always to production, use something else to switch your environments.
But there's a lot of great articles that show performance comparisons with that enabled and set to production or not. Just Google search with supply. Oh, sure.
So this is a quick example too. Sorry.
Nice.
Let me bring up the actual route first. So this is a super simple route, right? I mean, we add this actually to all of our applications by default, the health check. Just make sure the thing is alive. In applications that have to hit a database or whatever, we'll actually have it try to hit the path, a resource path, to actually make sure that all of its dependent connections are alive and stable, and it will reply back accordingly if it is healthy. But this is a very simple health check. Essentially just, it's a basic listening on the slash route. It's going to reply with the node host name if it's alive. So how do we just test this module without getting too overboard? So this is where the super test can come into play. So we require super test set to request. We're able to just utilize it, pass it in our Express application, and then just in behavioral driven semantics, just say, you know, get this resource, I expect the contact type to be JSON, I expect the response to be 200. When the response comes in, make sure that there's not an error, and make sure that the body was what we expected it to be. So we're able to essentially test the whole entire route without the application being up and alive. What proxy acquire lets us do too is we don't have a real OS. You know, we're using the OS module to get the host name. Well, that's not going to work during the test sequence. So we can essentially create a mock implementation for our fake OS. Proxy acquire, we essentially use the require statement to build the health route. And wherever there was a require of OS, substitute in the fake OS. So essentially with proxy acquire, you can take any require statement, substitute in a mock, and then run your tests. So you can substitute everything you don't want to be dependent upon for your run.
Great. So now we have a lot of small little deployable things, a lot of dependencies, and they obviously come at a cost. We stole this image from Netflix. Ours isn't that bad yet, but give us a year or two, and it very much well could be that way. So how do we make microservices easier to build and easier to deploy?
And at least the answer for us was containers, mainly just containerization. So the ability to wrap up a piece of software into a complete file system that has absolutely everything you need for it to run. They're guaranteed to run the same regardless of the environment. So I can take my container and I can run it on a virtual environment, my OS, I can put it on a server that's in QA, and then I can take it to production, and it's the same artifact across the board. And you know, we did this with, and we said we did this with things like jars, if you're familiar with like in Java, or your ear file, or take any essentially packaging software. But ultimately, when you got to the OS, who knows what administrator deleted this file system, changed this permission, changed this network share. It was almost impossible to figure out like what the state of the environment was. This is where containers give you that stabilization. They start and stop almost instantly. They efficiently use system resources compared to the traditional hypervisor. They're portable. Like I mentioned, you could really pretty much take them anywhere, and they're easy to configure. So Docker provides, you know, an implementation of containers that was, it is actively used in the software community. We chose it. There are alternatives if you want to look at Rocket or Odin, but we at least chose Docker given how active it is in the community. But they have this great illustration that shows how Docker is different than a traditional VM hypervisor. So with a traditional VM hypervisor, you have your host. So essentially, you have physical piece of hardware, the host operating system, the hypervisor software installation, And then with every application you're going to deploy, you have the full guest OS, all the libraries it needs, and then the application. So this stack, you're duplicating a lot in this layer as far as what you need. Docker takes the alternative approach and attempts to use, based on the Linux, all the different Linux distributions, to standardize and put the Docker engine in there and allow these containers to share the base OS libraries so that it's able to efficiently, essentially be able to start up, and that you don't have all the whole overhead of running the entire guest OS multiplied by however many containers you have across the board.
So Red Hat actually explained this really well, where they said that normally with a VM you have the virtual hardware and you have the guest OS, as Brad mentioned, for the Docker, and then there's separate user land where normally your applications run. But with Docker, you're only taking that user land mode and kind of packaging that up so that then you can deploy that separately via your container image. I believe in the appendix we have a slide there where there's like 4 different articles on Docker and kind of the fundamentals around containerization, how it actually works with the Linux kernel.
All right, so we took that initial set of problems that we had for Node.js as far as just, hey, it helps us solve, as far as the flexibility and what resources it starts fast, it's going to be available, and then we put Docker to help containerize it, make it deployable, and again, easy to start fast. But we still have tons of artifacts. I mean, with microservices and everyone being so small, and the fact that you use a lot of them to orchestrate, you have the problem of you need a stable build and deploy process. I mean, without it, essentially, how do you manage hundreds of items? It would be next to impossible to do it manually.
So what we look to help us deploy our containers and make sure they stay running is Kubernetes. It basically is our watcher to make sure our containers stay running. It's open source, it's started by Google. Now I believe it's part of the Cloud Native Foundation. They'll be kind of taking it forward. It provides a way to automate deployment, operations, and then scaling of containers. You can easily scale from, say, basically replicate a running container from, start out with one, scale up as basically as many as you need to as long as system resources are there. It ensures this container stays running. It basically is the watcher for you. If the container would exit for whatever reason, crash, it will spin up another one in its place almost instantaneously. It abstracts port management away from the developer. If you have any experience with Docker and you're trying to map ports outside the container, you'll realize quickly that that's a management task in its own. With Kubernetes, they kind of take that away for you. Depending even on if you're using, say, like GCE, it gets very simple. For us, we're using AWS, so it's slightly more complicated. But ultimately, it exposes on a port, and we can basically register that to an external load balancer. It also does the scheduling for us. It will basically, you set up a series of nodes that allow you to place the containers on some set of servers. It will look at the health metrics across those servers, and when we deploy a new container, scale up, or container dies and it's redeployed, it will look across those nodes and decide which one is actually the best fit for that container. And then, as kind of already talked about the lightweight deployment and horizontal scaling, it's a very concise definition for how you deploy the container, any environment variables that you want to define, metadata, and then the service definition as well, and if you're exposing ports outside the environment.
Yeah. Could you talk a little bit about the scaling? I feel like we're always scaling things in directions that I don't fully understand.
So we would always scale, I guess, horizontally. So we never would scale up as far as the resources that are provisioned for a container. We would actually just start more instances of that container. So that goes to like, yeah, exactly.
That's what it means.
Yep. So that's where it needs to be stateless, right, for us, so that we can scale up and add more containers, and it's not really affecting anything else that's already existing running as far as that exact container. And then we also have where it stores application configuration and secrets outside the container. So in a lot of cases, we may have certificates if we have to do SSL or some type of other secret that we need to say we have to access some other API. Kubernetes allows us to basically kind of set that outside the container. It has a different kind of data type that you can define up front so that when you can deploy that secret and then give each container access to that, and it's mapped inside the container in a way that it doesn't affect kind of that deployable container artifact that you put in your Docker registry. And then it also has a concept of kind of grouping containers together. You don't, basically Kubernetes doesn't deploy just say a container, it has the concept of a pod, and a pod can be a group of In a lot of cases, we deploy a single container, but in other cases, say you want to proxy something in front of that, where you need some type of like Nginx or something in front of what you're actually deploying for your application. You can easily group those together and just expose the port that Nginx is basically listening on.
What are the other solutions in space?
So at the time, I guess Docker Swarm was still in beta, so that was kind of ruled out. We had some vendors that we were trying to fairly closely align with, so that was kind of part of what we looked at. We also just looked at running Docker on its own and using some just infrastructure automation tools to kind of manage that. And ultimately, I mean, that would have just been a lot more work for us. And this was kind of provided a lot of that for free and was fairly easy to kind of rely upon. And it has a huge community around it, so I think that was part of it as well. We didn't, I guess, Mesos is probably another one that's popular, and we didn't necessarily evaluate that one too fully at the time. That didn't have a lot of, I guess, organizational like push behind it to evaluate that option.
The Mesos, I mean, probably 2 months now, they've essentially embedded Kubernetes even as an option to run inside of Mesosphere. So, and they were even trying to partner even with that effort. But there are other, like, if you want to be able to just essentially take what you have for Docker containers and, you know, get out as quickly as possible, Amazon has container service. Azure has a container service. Obviously, when we mentioned Google essentially backs, you know, they use Kubernetes as their container engine, but any of those are pretty much click button. You'll have essentially a cluster to run on, and you just tell it what container you want to run, and you're good to go. We were given like essentially kind of some guidelines from the outset that we need to be able to take this and run on any cloud provider at any time. Then we really can't use any lock-in solutions. We really need to be able to have this whole solution to be able to move anywhere we want. That's why at least it would be something like Kubernetes or Mesosphere.
And we did talk about Cloud Foundry as well. I forgot about that one. At the time, that one didn't support Docker containers. I believe they had a Diego project, but that was beta. It looked like they were potentially going to be doing their own Docker implementation. And so that didn't seem very interesting to us. We liked the fact that Kubernetes still uses Docker kind of underneath.
Even taking one more step back too, like you could even say like, why do I even need containers? Like, why don't I just take my Node application and use something like PM2 and just give it a ton of Node applications and let it just run? I mean, stability-wise, you're still hoping that that OS container stays stable, because the moment that fails, everything's going down with it. You don't get any isolation too. I mean, all these are sharing the same memory and the same machine. So if you have a process that goes rogue, it could very well cripple a lot of other things. So that's, I mean, containerization provides a lot of benefit over to just running your process just on the machine by itself. So this is a really, really super slimmed down picture of what a Kubernetes cluster really entails. Ultimately, the Kubernetes cluster has n nodes. However big as you want to make this, just spin up as many machines. Each configuration of the nodes is really identical. Our provisioning literally treats them identically. It says we provide a variable how many we want. It spins up that many instances or to serve as hosts in the Kubernetes cluster. You essentially, everything you do with the Kubernetes cluster is interfaced through an API. They built a GUI over the top of the API for simplicity that we'll show in a minute, but you essentially said in Kubernetes cluster, I want to run, X, Docker container with this service. So this is like a hello node that they're firing up. Kubernetes has a scheduler that essentially says this is work that needs to be put on the cluster. It's then scheduled and placed onto nodes who have the best availability. So it'll look at all the nodes, run a simple computation to figure out who's got the best capacity, put that node or nodes, however many you ask for, on that box. So when you kind of like, how does it scale out? Like this, essentially in this example, they just said, well, I want 5 of these hello nodes, and it just goes essentially and places them whoever's got the best capacity to service. The definition for it is simply just how many replicas you want, what image it has. You can specify the environment variables, the secrets, essentially all the definitions of what it should run as. Once the work is exposed, all the clients, when they hit it, they're essentially going to hit any number of the nodes through a load balancer. Any one of the nodes can essentially take that request, see through the Kubernetes API who's available to take that request, and essentially broker that work off. So, like I said, as many nodes as you could go, you want to run wide, you could. I mean, so if you're running in capacity, just keep adding and tacking on more and more instances to run the work.
So now we've kind of shown where you could basically have a definition of what you're putting in your container, how you're building your Node application. But that basically, so far what we've shown is you need something to easily scale that. Without the same capability in your infrastructure, that potentially is not going to be stable. You won't know what's running where things can just be deployed kind of wherever they fit best. Since the static definitions of where things are actually deployed and running is gone, we need some way to actually try to help mitigate that. And so what we look to that is automated and immutable infrastructure. So public cloud providers like AWS, Azure, DigitalOcean, basically any of the major cloud providers expose almost everything probably everything they do via an API. That lets you create infrastructure of all types. So that's creating your VMs, defining even your networks, creating load balancers, creating separate disks that you can attach your instances, and you can basically script that infrastructure, and we've basically done that for our entire environment. And so kind of throughout this process, from the very beginning, we wanted basically everything to be code. All our infrastructure, all our services, all our networks ends up being checked into Git, separate Git repos that then we can deploy and version and basically have confidence of what's in QA, our kind of prod fix environment and then production. So we kind of like put some guidelines to code by. Number one, we don't log into our instances, and specifically in production, but also that's the goal for non-prod. The only ones we actually log into is kind of our POC environment. That environment's where we're basically trying to learn how we can install what we need to on the instances, keep track of every command we run, and we basically put that in an Ansible script or in an Ansible playbook. And then we would replay that across all our environments. So, something that maybe takes days, hours, but depending on what it is, we're hoping to cut down them 5 minutes. And I guess throughout kind of all our environments, the first environment's the hardest, and after that, that's when the payoff really starts. Especially with, say like project managers, when you're getting close to deadlines, we got a lot of pushback saying, we just need to get an environment, and we had a fight to get that first environment. Then after that, when they wanted the second one, it was a few hours and we were done. And then you just continually, if you have issues with these instances, or VMs or containers, we just destroy them and create new ones. We kind of limit how many scenarios we're actually coding for, by just the fact of we know we can easily create new ones, so why worry about trying to fix what's there? And that's been very beneficial for us as we troubleshoot, deploy new infrastructure, make updates, things like that. And kind of like I mentioned, we just replace. We don't want to have people logging in trying to fix it, forget a step, not check it into Git. You want to make sure that whatever you do, you check into Git, and then you basically would run that playbook from scratch, creating a new instance. And then also, you want to be able to run that, basically have an idempotent playbook. So you want to be able to run that playbook over and over again and just get that instance back to a known, good working state. That way we know what's there. We have confidence in what we're deploying, and we don't have to worry about some manual change or something, basically configuration drift.
So how powerful are the machines that you're running to sort of like, there's a production issue and you're going to fire up a bunch of these things, like how powerful are they to like be able to handle that? Just like 16 gig MacBook Pros, or they?
So I guess for when we're deploying, we do, as we're developing, we're trying to just build an individual Docker container. We will show in a few minutes like a local Kubernetes cluster, but I think the vagrant images are like 500 megs of RAM, small disks. They're headless, small little Linux images. Depending on your distribution, they'll obviously vary in size, but if you do like Core OS or like any type of small container-specific operating system, that's going to be fairly small. You probably still need at least a few gigs of RAM. I'm guessing not less than 8 to have an optimal experience. But I think in this case, 3 images, 500 megs of RAM apiece, and probably initially a 300 meg OS image that I think becomes like a loaded gig, and then depending what you deploy on that, obviously what you're doing. But in our general development, we're not necessarily having developers creating microservices deploy the whole Kubernetes stack every time. It's good for people to get an understanding of how everything works, and then we're to the point where we're actually developing applications against that API to provide certain functionality for our environment, and that's when you need to have that local environment as well, that you can kind of code and deploy against just to test things out.
I mean, besides even like in a prior example we did, we just fired up, you want to go play with this stuff, GCE is a great example because they're gonna, if you haven't already signed up, you're gonna get $300 of credit automatically. And then I started my cluster at the beginning of April, and I looked not that long ago, and I had only used about $40 of my $300 running a 4-node cluster of their basic instances. And then during the demo, we fired up a Plex server, MySQL, 2 different blog wikis. Like we fired up essentially like about 8 different applications. I didn't realize I left them up for like 2 weeks. I mean, so the process consumption by it, overall because of the containers is minimal. It's not like you're not churning up huge amounts of CPU cycles or huge amounts of RAM as a result, because you don't have all those idle guest processes just sitting there spinning.
But it does go to the fact of lightweight runtimes, right? I mean, that makes sure that we can deploy many things to small scale environments.
I mean, another good example too in production, we're running the second smallest dedicated. I mean, Amazon limits what instances you can buy once you go dedicated, just because of security concerns. But we're now debating going to the absolute smallest. We're using like a fraction of our CPU and memory, and it's like, okay, we might as well get our money back off the instance and then scale back to the smallest we can buy.
Because we're limiting how much memory Node can access, just because our services are so lightweight. I mean, they're not doing a lot. They're basically grabbing usually a row from a table and returning it very fast. And so right now we don't have a lot of reason to create large instances beyond what kind of our risk management team is deems kind of the minimum instance level we can have, just so that we have basically all our VMs are deployed to a dedicated underlying infrastructure that we are assigned. So now we're just going to do a quick demo. Did anyone try cloning the Git repo, or basically doing the install that was defined in the repo? Maybe? No? All right. So this is the Kubernetes dashboard. So this provides kind of an easier way to kind of get familiar with how to deploy containers inside Kubernetes. If you deploy in GCE, I believe this comes as part of the standard installation, and you can kind of hit this UI. So we just had a few containers that we were going to deploy. So starting out, I'll just deploy Nginx. Should have wrote down the port. I think it's 88. And so here, basically what you can see is now it's trying to download the container. It's downloading the container just from Docker Hub. We're just using people's public images. Obviously, if you're deploying this in your production environment for your company, you probably don't want to pull containers from Docker Hub. You will want to build your own containers and have whoever needs to sign off on whatever code's running on your environment. Review that in advance. Yeah, code question or just that disclosure. Even with your base container, so Docker, you have kind of a base kind of OS layer. You obviously want to make sure that that's stored in some local Docker registry. Somebody approves that, and you would reuse that across all your Docker containers. But for demo purposes, this makes it easy. And so we'll just, okay, so in this case, this container is already running. If we want to look at the details, we can click on logs. And there's no logs, so we'll hope for the best. So I'll just click back here, we'll go to events. So you can see that it started the container. So going back here, we can see that it's on. In this case, we kind of have some crazy port numbers because of what we're doing locally. Like Brad mentioned, GCE kind of extracts some of that away. So we'll I just need to get a node. So that's just the IP address of one of the Kubernetes nodes that's running. And then I need the IP address and the port.
So the app he's deploying right now, and the Sublime example, the test that I brought up, that's actually the same project that was on the intro slide. So this is essentially Facebook's React example. So if you go to essentially the Facebook GitHub, go into the examples and look at their React to-do guide. Essentially, it's that wrapped up with Node, and I wrote a tiny little Docker container to essentially take that, start from nodes, add our application in there, do an npm install, build our client.js, and then essentially invoke nodes, start it. So it should be pretty much the to-do example just wrapped up.
All right, so it's running. So that's 32.221. And then, so the health route that Brad showed. So there you can see the health route. So this is that React app. And then Nginx might have been 8080. Right, so now that's 469. Right, see what's wrong.
So, Brad, while Brian's doing this, how did your team learn this? Is there good documentation, good training, Pluralsight Code School, or did you just kind of do it?
So, Node, like I said, obviously there's a lot of good examples for Node. I mean, the number of different, like I think, doesn't even front-end masters or something even for Node now?
Probably.
I mean, obviously Pluralsight does Code School. So a lot of that was just good, starting as far as just the basics, but over time, that's what I meant, the production, the production qualities. Some of this is so new that there isn't a lot of good reference points for like production, getting ready for the production issues that will arise. Kubernetes does have actually very good documentation. They have pretty much their whole API and Swagger documentation. They have a whole Kubernetes.io. If you go there, they have a great explanation of the product, the features it provides. They're constantly churning out new releases, so they're constantly adding more and more functionality to it. As far as Docker also is pretty good on their documentation. I mean, that's been now at least gaining so much wide use that so many people are contributing to it. The documentation essentially has evolved over the past year to be, I'd say, pretty robust.
Yeah. I mean, in general, sometimes with Kubernetes and Docker in general, you are going to GitHub issue trackers, and that might just be the way it is. We've kind of gotten used to that. It's not just those things, but as you pick your tech stack, that may be inevitable in some cases if you want to use some of these technologies that are evolving very quickly. So this was 80. I don't know why I did for his first time, but yes.
How do you manage all your microservices? Like, I'm not sure how they work, like name-wise and routing.
So I guess we kind of just find like a standard kind of base API as far as naming or route naming convention. And then in our GitHub, or not GitHub, we use GitLab, but we kind of have a specific group for basically all our microservice related code, and then for infrastructure code it's in a different repo. But ultimately, kind of just the team decided on a naming convention.
Is there like a main service that runs the microservice?
No, so they're all independent. The kind of that having those nested dependencies kind of make it so that we can't deploy just one thing and not worry about breaking something else. We need to make sure that basically our microservices stay flat across all the APIs that we're exposing. We do have kind of an API management layer on top of that people go through to call the APIs that provide security, some analytic information that we need to know about who's deploying them. You definitely want to make sure that as you're setting up microservices that you don't kind of have nested dependencies by kind of chaining microservice calls together.
I
they
think
like separate subnames or subdomain names or like different ports that people are showing or how is that?
Well, there's still an API gateway in front
Yeah.
that is routing. So essentially, there's more or less a proxy. I mean, via the gateway that essentially can provide one domain, just context routes after that allow you to essentially channel your requests down to different paths.
And that helps, like, if you're doing some type of, say, like, credential verification, right? It's fairly easy from that perspective to have kind of an API management layer, do the credential validation, and then kind of act as a reverse proxy also to kind of pass those requests back to the backend microservices.
And if you don't even want to go with like a product, obviously you could just throw Nginx in front of them and let that essentially just be a simple potentially Git repository with your Nginx configuration. Just put new entries in there for each of them coming in, and just be able to bound all the context routes off of it.
And that makes sure that, like, obviously, say 80 or 443 is usually potentially the only ports that some proxies allow you through, so that very much becomes a requirement in some cases.
So it wouldn't be a talk without the obligatory text slide of what our environment looked like. So you're asking to like API gateway. We chose Apogee. It provides a lot of very, I guess, sophisticated UI to manage all of the different all the different APIs that you could define. Great tracing functionality. As far as the development side, so Vagrant, so Docker, well, now with the new beta, they're trying to make it so it'll run more natively on Macs as well as Windows. But we use Vagrant essentially to create our development environment, so we can spin up quick Linux instance, put Docker on it, and be able to essentially run any type of application that all the different microservices that we have. Obviously, Node. We use MySQL in our cloud for our relational data store as a cluster. Docker for all of our virtualization. Kubernetes for management of the virtualization. On the infrastructure side, all the infrastructure is provisioned by Amazon, with Ansible doing all of the coordination and essentially the infrastructure as code, defining what that whole deployment looks like. And then, like I mentioned kind of earlier, like getting insight into the running applications, I guess we kind of saw as key early on. We used this kind of a variation of the Elk stack. So we have fluentd running on all of our instances, looking at all of the logs coming in from both the OS and Docker through the journal. All those logs are forwarded to a big Elasticsearch cluster that are aggregating all those, and then Kibana is doing all the visualization of the logs. So across all of our environments, we can essentially search 25, I think we're about 25 or 30 million log entries coming in a day, just in seconds, because of how fast Elasticsearch is able to index and essentially spin through that data.
And that helps us make sure that nobody has to log into the instances either. They can't use an excuse that log file. And so this is just kind of some of the things that we learned along the way. Architecture failure, as we mentioned, we expect our containers to fail. Kubernetes is going to bring them up. Same thing with our instances. Make sure that as we're basically orchestrating and automating our infrastructure, it's architecture failure. We want to make sure that basically we stay available, and without architecture failure, that's not possible. We also tag our releases for prod and run our current master development in our non-production branches. So if we want to deploy to our production environment, we basically have to tag a specific Git SHA, and then that is what's actually deployed to production. That way we have a static pointer to our code. We'll never delete those tags either. And we use that kind of across our infrastructure as code and our Docker containers as well. So right now we don't have like a private NPM repository. We're just specifying specific Git repos and then the tag to pull specific versions based on that, whatever tag specified. And then there's different purchasing considerations when you start automating your infrastructure as far as kind of vendor purchases or vendor decisions. GUIs are gone. They're not going to help us really with what we're trying to deploy or build. If it doesn't have a text-based configuration file or some way to easily automate it via an API, I'm really interested in that tool. So yeah, that was, I would say, a big learning experience for us going into it as we were making some vendor product decisions. That wasn't a huge priority for us, but I think overall, that's probably one of the things that will have a big organizational impact as a whole across NM that we can kind of give back to our project, from our project. That's an important decision-making factor, how we actually make purchasing decisions. Before we didn't really care what the installation guide looked like. It was more about the capabilities of the product that we were looking at, purchasing provided. That definitely will be the case going forward. And then orchestration can make security easier. So this is, I guess last time this got a lot of questions, but ultimately we can basically have our infrastructure automation take care of a lot of the creating the certificates, deploying things for us. We don't have to worry about somebody needing to know keys. We use different tools basically to kind of abstract that away from us, so that we can make sure that we can deploy things in an automated fashion and keep things running. And that's all we had. And then we do have the slides at the SlideShare link available as well.
Any questions?
Say you had a cluster of MySQL cluster.
Yeah. So it's not an NDE. It's not an NDE cluster. There's just basically a master slave with a secondary master slave there as well.
Do you have any idea how far that is going to scale with your highly available web service, microservices?
I guess right now we're not really too worried about load on that, since the scheme that we're putting there is fairly flat, and we literally are pulling out one row at a time. It seems that the scale is quite a bit. The reason we kind of the deployment configuration that we have, that was the way that they could make schema changes and go down.
So I mean, when we were running, I guess that's the 150 transactions a second. I don't think we got above. I don't know if we got about 20% CPU, barely any memory movement at all in those boxes, just because it is spread 4 wide essentially across the reads.
We do have a somewhat complicated load balancer to make sure that configuration works.
You're using read heavy or
We're only doing reads, basically. Yeah, we have not worried about taking writes for kind of this flattened kind of, I guess, speed layer.
How did you guys approach it? A lot of the stuff can be scary, especially for large companies. It's like, well, we've done it this way for forever. Why would we want to do it this way? Like, can you just kind of speak to how you kind of got that stuff approved, basically?
So I think the acquisition helped kind of get us a license to look at things, and then it was just making sure that you put the time in to make sure you were successful in the things you were trying. As long as you had good technical reasons for what we were selecting, I think we had good, I would say, leadership support in continuing to move forward with that. And then it was just a balance of kind of, if we had certain kind of vendor preferences internally that didn't really impact our stack, just kind of going with those, because ultimately that didn't impact kind of what our ultimate goal was and what we were trying to achieve, as long as it kind of compromise kind of the architecture of what our end goal was.
I mean, there's a portion of it too that there was recognition that of all these different platforms that at least the company's been through the years, there were a lot of bad promises about what availability would be and what infrastructure could be. So I think there was a desire to try to decouple this and see what could happen if you did approach it, not as just like, we had an independent organization, so you had one team who would do your infrastructure, like your web server build, another team who would do your MySQL build, another team who would do your CD, and with all the decoupled teams, no one felt responsible, I guess, for owning the entire solution. So I'd say that's more about empowering the team to you're owning the whole thing, soup to nuts. You entirely own the whole solution, and the only way to do it is essentially get it out of our data center. I'll say that was part of the drive for the cloud of just without relying on all these teams to actually give you a server in the server room. It's much easier to just say, here's a credit card, go fire up an Amazon account.
Slightly more complicated.
But step one is acquire a startup.
Doesn't hurt.
Yeah.
I think it was credit
Alrighty.
whenever I look into Kubernetes, I keep running into like this flannel thing.
Sure.
You use that. What is that?
Yeah, so those cloud providers don't let you basically broadcast across their networks, and so you need some type of overlay network to allow that broadcast for how I guess internally Kubernetes communicates among the nodes, and so you need some type of overlay. Flannel, Weave, Open vSwitch. I think Flannel's probably the easiest. That's what Weave went with. I believe I've read that there's some type of performance downside of Flannel. We haven't hit it yet. If you look at maybe some other kind of package solutions that are out there from different, I guess, Linux vendors, they may use Open vSwitch underneath. The documentation for that wasn't great and had to be translated to understand what it was doing. And so we didn't go with that initially, but as we continue to evolve and mature our stack and constantly looking to see what's the best technology, we could easily migrate to say Weave or Open vSwitch if that was deemed a better option.
And then even the install for your core OS is using Flannel, and the covers almost all the guides end up using Flannel. It is, I mean, from the default configuration that's at least in there, it is dead simple to kind of just set up and get running. In GCE, it's not even going to be needed. I mean, they're already a layer 2, so
yeah, so that's definitely probably the easiest way to get started. Yeah.
Do you guys use Netflix gas monkey to do testing for site reliability type of stuff?
So right now, I'd say that didn't kind of meet what our MVP was. We definitely have some interest in doing something similar. But yeah, I mean, I would say that's something that we're probably looking at, still trying to deliver this year. Right now, unfortunately, that's something we kind of have to do manually. That we've done, or Amazon takes down the instances for you and you find out if you're reliable. Which happens.
Are you guys in multiple Amazon regions?
Single region, two AZs. Soon to be, yeah. Some stuff will be a third AZ as well.
multi-region this year.
Hopefully, yeah.
Just kind of curious, like Netflix is doing gas monkey doing their business hour
Sure.
because people watch movie at night. So that means for you guys, when do you guys test it?
So far we'd like to do that during the day when everyone's there, awake, ready to go if we have any issues. But I would say, I mean, that's one of the things that we're still a company that's not used to that sort of thing. I think that's one of the things that kind of as we mature, get some confidence in what we built, hopefully we can encourage the org change to allow us to do more deployments during the day, do more of the chaos monkey during the day, have faith, maybe do canaries, right, where we're basically part of our kind of certification for a build is we're giving it so many requests, and then that's the last step to certify before we go to prod. We're hoping that eventually we get there, but kind of right now we're not quite to say that mature. Even like a blue green flip style, that's a capability also. Hoping to do this.
Just need to wait for Amazon.
Well, some instances were out last week. Yeah.
Do you synchronize your state deployments, like migrations and seeds, versus your stateless migrations? Or not migrations because it's immutable, but upgrades.
What, are you talking about as far as like our data stores?
Yeah, so basically your MySQL is your state, your Docker images are your stateless. So how do you synchronize those two deployments?
Well, so, I mean, everything that happens, like, so MySQL, and even with our schema, as we said, essentially it's got to be backwards compatible. So on the data side, that essentially means no modification of columns, no deleted columns. If you want to introduce anything new, it's, new column, double reference until you can obsolete the old. So everything can be put out in preparation in advance. Like, obviously the data side's got to come first before the service, but we're not essentially being bound on, like, well, these things have to go together. Like I said, the only way we achieve it is pretty much by banning, anything that's not backwards compatible from going out there. And of course, that does come on the expense of duplicating data until you can get people off of the old.
And then you deprecate the stateless portion of it after so much time has gone by?
Yeah, I mean,
Or it's still out there forever.
No, I mean, that's the part with MySQL, it's easy with an API to say that this is deprecated because you can start providing that, even in your API and your documentation. The database, other than us just essentially notifying people that it's going to be going away, it's hard to do it other than taking a chance and in a lower test environment, just wiping the column and then see who's going to scream at you because you pulled it.